In this question, it is given to us that let a function g takes the interval 0 to 4 2r be defined as gx equal to this thing, then the number of points in the interval 0 to 4 where gx is not differentiable is dash. You have to fill in the blank. Actually, the difficult part to understand is this one. What is the meaning of this? The meaning of this statement is, so far as x lies between 0 and 3, the value of gx will be found with the help of this expression. And how to find the value with the help of this expression is, I'll make you understand with the help of an example. Suppose you have to find the value of g2. Then I will make t vary from 0 to 2, and I will find all possible values of t cube minus 6t square plus 9t minus 3. And out of all possible values of this expression, after making t vary from 0 to 2, the maximum answer will be the value of gx. For clarity purpose, I just repeat that if I want to find the value of g2, I will make t vary from 0 to 2, and I'll put all the real numbers from 0 to 2 in this expression. And after putting all the values of t from 0 to 2, the infinite number of answers I will be getting. Out of them, the greatest one will be the value of g2. And if x lies between 3 and 4, then it is very simple. The value of gx is found with the help of this expression. To redefine this portion, first of all, I draw the graph of y equal to t cube minus 6t square plus 90 minus 3. And it is clear that it is an odd degree equation and coefficient of maximum power of t is positive. Hence, the graph will come from below and finally go upward. And to find the points where the graph will be turning, let us find the value of dy by dt first. That is 3t square minus 12t plus 9. Putting it equal to 0, I get t square minus 4t plus 3 equal to 0. That is, I get the value of t as 1 and 3. And keeping all these information in mind, I can say the graph will be coming from downwards, cutting y-axis at 0 minus 3. For clarity purpose, first I am drawing the complete graph. Hence, the graph will come from below and it will turn at t equal to 1. And when t is equal to 1, the value of y is also 1. That is, this point is 1, 1. And then second time it will turn at t equal to 3. And when t is 3, we can easily calculate the value of this. And when t is equal to 3, the value of y 27 minus 54 plus 27 minus 3, that is minus 3. Therefore, the graph will again turn at 3 and the value of y will be again minus 3. But actually we have to keep the value of t from 0 to 3 only, because t can go maximum up to x and the maximum value of x is 3. Hence, beyond 3 I will be rubbing the graph, and this part of the graph will also be rubbed because here t is negative. Hence, this is a graph of this equation where t lies between 0 and 3. It is clear from the graph that because every time t has to vary from 0 to x. So far as the value of x is less than 1, say x is here, then as I will make t vary from 0 to x, on the graph will be going from here till here, from here till here, and out of all these values of y, that is the values of this, the maximum value of y is here. Here t is x, therefore the value of y at this point will be x cube minus 6x square plus 9x minus 3. And once x has crossed 1, say x is here, as I will make t vary from 0 to this point, on the graph will be going from here till here, and out of all these values of y on this portion, the maximum value of y is always 1 if t is varying from 0 to x, and this situation will remain same so far as x lies between 1 and 3. That is, if x lies between 1 and 3, as t will vary from 0 to x, the maximum value of y will be always 1. Hence, this portion will be broken into two parts. First part will, if x lies between 0 and 1, and second part, if x lies between 1 and 3. For x lying between 0 and 1, because I just now told the maximum value of y will be from here as x cube minus 6x square plus 9x minus 3. And if x lies between 1 and 3, maximum value of y is always 1. Hence the value of gx in redefined form will be gx is equal to x cube minus 6x square plus 9x minus 3, so far as x lies between 0 and 1. For x equal to 1, it is clear that both are giving same answer. And 1 if x lies between 1 and 3. And if x lies between 3 and 4, the value of gx is 4 minus x. It is clear that between 0 and 1, it is a polynomial, hence always differentiable. Between 1 and 3, gx is a constant function, hence differentiable. Between 3 and 4, again it is a polynomial, hence differentiable. Means the chances of non-differentiability are only at 1 and 3 only. And I'll be checking the differentiability by shortcut way. By proper formula, if I want to check the differentiability at 1 and 3, that will be lengthy. Therefore, shortcut way is better, and most of the students are knowing the shortcut way of checking the differentiability. But still, if you don't know, you can see my video lecture of differentiability of JEE mains level. But as you are knowing that before using the shortcut way, you must check that the function should be continuous, because if the function is discontinuous at some point, then non-differentiability automatically comes. For x equal to 1, it is giving the answer 1. Left hand limit is also 1. For x equal to 1, this is giving 1. Hence, it is clear that at x equal to 1, the function is continuous. Similarly, it is continuous at 3 also, very easy to see. And now, because it is continuous at 1 and 3, now let us check the differentiability at 1 first. For g dash 1 minus limit x tends to 1 minus derivative of this, that is 3x square minus 12x plus 9, and this is 0, and g dash 1 plus is clearly 0 because the derivative of 1 is 0. Hence I can say the function is differentiable at 1. And now for checking the differentiability at 3, it is clear that g dash 3 minus is 0 because the derivative of this is 0, and the value of g dash 3 plus is limit x tends to 3 plus, and derivative of this is minus 1, hence the answer is minus 1. Therefore the function is non-differentiable at 3, hence there is only one point of non-differentiability, hence the answer to this question is 1.